Hello and welcome to the chemistry solution. This tutorial is on dilution problems. When you are diluting a more concentrated solution, you're increasing the volume, but the number of moles of solute in the original solution stays the same. So the initial concentration times the initial volume will equal the final concentration times the final volume. Sometimes you see this written M1 times V1 equals M2 times V2, and M1 times V1 equals the molarity of the first solution times its volume, which equals M2 times V2, which is the molarity of the second solution times its volume. It's just another way of writing initial and final. And if you look at that given equation, if you look at the first equation, initial concentration times the initial volume, you know that if your initial concentration is in moles per liter, what's really important is that your initial and final concentrations, or M1 and M2, must have the same units. And your initial and final volumes, or V1 and V2, must also have the same units. If you have concentrations in molarity, moles per liter, your volume does not necessarily need to be in liters, but your initial volume and your final volume need to have the same units, just as your initial and final concentrations must have the same units. If you're asked to solve a problem where either your volumes have different units or your concentrations have different units, it's going to be necessary to convert one or the other in order to arrive at concentrations or volumes that have the same units in order to use this equation. Let's look at an example. How many milliliters of a 2.5 molar NaOH solution are required to make 525 milliliters of a 0.15 molar NaOH solution? We know that the molarity of something times its volume will equal the molarity of our other solution times its volume. Let's write down the information that we're given. Our first concentration is 2.5 molar, but we're asked how many milliliters of that solution are required, so we don't know the first volume. The final volume that we want to arrive at is 525 milliliters, with a final concentration of 0.150 molar. Because our concentrations have the same units of molar, we can plug these values into our equation. In order to solve for the volume of our first solution, we need to divide each side by 2.5 molar. This allows units of molar to cancel out. And we're left with the volume of our 2.5 molar solution required to be equal to 0.150 times 525 divided by 2.5. And because the units of molar canceled out, we're left with units of milliliters. So the volume of 2.5 molar NaOH required in this problem is 31.5 milliliters. Let's try another example. If 45 milliliters of a 6 molar HCl solution are diluted to a final volume of 0.250 liters, what is the final concentration? Again, we will use the equation M1V1 equals M2V2. And I think it's helpful to always write down first the information that you're given. The molarity of our first solution is 6 molar, and the volume that we have of it is 45 milliliters. We're asked what the concentration would be when we dilute the initial solution to 0.250 liters, so our second molarity is unknown. And that's the value that we'll be solving for. But if you look at the two volumes given, you'll see that one volume is given in milliliters and one volume is given in liters. Now it doesn't matter if we convert volume 1 to liters or if we convert volume 2 to milliliters, but we need to change one of them so that they have the same units. But let's look and see what would happen if we just plugged in our values the way they were. We would set up our problem according to our given equation. In order to solve for M2, we would need to divide by 0.25 liters. But what you'll see is on the left side of your equation, milliliters and liters won't cancel out. And we need the volume units on the left-hand side to cancel in order to be left with an appropriate unit of concentration. So like I said, it doesn't matter if we change milliliters to liters or liters to milliliters, but in this case, I'm going to change volume 2, which is 0.250 liters, to milliliters. And I will use my volume in milliliters to plug into our M1V1 equals M2V2 equation. Now when we divide each side by 2.5 times 10 to the second milliliters, units of milliliters will cancel out, and we'll be left with a concentration in molar. So in this case, the final concentration after we've diluted 45 milliliters of a 6 molar solution to 0.250 liters will be 1.08 molar. Thanks for watching the chemistry solution. We hope you enjoyed this tutorial.